to Prodigy Educlasses. So I will be continuing the chapter on language of chemistry today from the Valency part. But before that, I'd like to tell you one thing, that so this is a period of crisis we are all facing, and especially in the phase of education. And most of the children are facing different problems with their chapters, and they are not liking to study at home. Naturally, because always we do not get all this infrastructure from all types of schools. So you can ask me if you have any queries, if you have any requirements on any of the chapters on chemistry, you can ask me, and please mention that in your comments. Okay? I hope you are enjoying. So this class is on Valency. I told you the language of chemistry, how to make the formula of a chemical compound in my last class, and there I told you that a chemical compound is mainly composed of two parts, the positive part and the negative part. They are called ions and radicals, positive ions and radicals, negative ions and radicals. For the positive ions and radicals, I will be telling little later. Now let me say about the valency of the negative radicals. Okay? Very interesting thing that negative radicals, you see, they may have valency, they will all have valency minus, negative. They will have valency minus 1 or minus 2 or minus 3 or minus 4. Okay? There are some interesting things to remember here. I am telling you one thing, perhaps you have not noticed that any negative radical beginning with the letter S must have valency 2. This is my observation. This is not written in book. Okay? Any negative radical, say suppose sulfide S, so its valency is minus 2. Sulfate SO4 valency is minus 2. SO3 sulfate valency is minus 2. S2O3 thiosulfate. This is called thiosulfate. Its valency is minus 2. Silicate SiO3, its valency is minus 2. You see that any negative radical, wherever you find a negative radical, that will have a valency minus 2. So I have reduced a lot of things from your memory. Just find any negative radical beginning with the letter S, you will remember that the valency is minus 2. Okay? And along with this, the rest which has valency 2 is the most abundant thing, oxides. O, they have valency 2. Carbonates, CO3, they have valency 2. Manganate, MnO3, MnO4, they have valency 2. Chromate, CrO4, they will have valency 2. Now you see, there are some charts in our books, and in the charts of the valency, it's written the valency, which one has valency minus 1, which one has valency minus 2, minus 3, and all these things. So this is just an example how to remember. Suppose oxalate. Oxalate, it's written COO whole 2 and its valency is 2. Now oxalate is such a compound, it does not mean it's an organic compound. You know that oxalate means it's present in amloki. So oxalic acid, oxalate utar salt, oxalic acid থেকে oxalate ion টা আসে. Now you see that COO and COO with one vacancy here, one vacancy here. If it is H, pronounce it as kuh. So this is oxalic acid, and when 2 hydrogen ion are eliminated, that means 2 positive goes out. That means what happened? It gets a charge of minus 2, and the formula becomes COO, again COO, that means COO whole 2. This concept you must require to make the formula of the compounds. Okay. Another thing, you see, for important valency negative radical of -1, you see, what are they? Say hydroxide, OH, the most important one, which has valency 1. Hydroxides, then any halides, chloride, fluoride, bromide, iodide. I told you the element itself means ides. So all these ides, they are halogens and they are termed as halides. Halides, they have valency 1. Hydroxides have valency 1. Nitrite and nitrate, they have valency 1. Acetate, CH3COO, they have valency 1. Okay. And other than lead compounds, any negative radical beginning with P, okay, they must have valency 3. Suppose phosphate, PO4, PO3, phosphite, P. What did I say? Any negative radical beginning with the letter P, but that must be a lead compound, other than lead compounds. Lead compounds also begin with P, isn't it? Pb means lead. So PO4 phosphate, valency 3, PO3 valency 3, P. So these are the some shortcut process to remember the valencies of these substances. Okay. And we have got chart from the book, we can get the chart from the book, and now we have to make the crisscross. That means the metallic part exchanges its valency with the non-metallic part. That means negative radical, the valency of negative radical goes to positive and valency of positive radical goes to negative. I know this process from class 8. Now what about the positive radical? What are the valencies of the positive radical? You see, for the positive radical, you see, we have 3 categories. They may be +1, +2, +3, +4. So +1, do you remember that poem? Some little hungry pigs make a silent cry. Later I am describing about this task. Some little hungry pigs make a silent cry. These are the common elements which have valency 1. Some stands for sodium, Na. Little stands for lithium, Li. Hungry stands for H. Hungry stands for H, means hydrogen. Pig stands for potassium, K. Make stands for Hg. Make and Hg, why? Because it is pronounced as mercurous. It begins with N, isn't it? Mercurous. A means not aluminium but ammonium. Ammonium. That means NH4. Silver means Ag, and Cry means copper, Cu. You see, so what is the shortest way to remember the common elements which are valency 1, positive 1? Some little hungry pigs make a silent cry, which literally means কিছু ছোট ছোট ক্ষুধার্ত শুয়োর নীরবে কাঁদে. Now you see that I have given stars here. Why stars? These 3 metals in the chart of valency +1 can also have other valency, and this is called a metal, a substance, an element with variable valencies. That means there are many elements which can have more than one valency, and out of one, these 3 are one of them. Remember, one is silver, one is the lowest state. So silver, it's called argentus. Then argentic is what? Ag 2+. Cuprous, Cu. cupric Cu 2 plus, and mercurous Hg plus. Mercuric means Hg 2 plus. Now suppose I have not been mentioned in any exam whether it is As or Ik. I don't know. I have given silver chloride. I don't know. Silver chlorides have not been mentioned. Argentus or argentic. So, if it is given only silver, think that it must be Ag plus 1. That means A state is considered. If it is silver, then think it argentus. But if it is copper, don't think it is cuprous, it will be cupric. So copper and mercury, if it is not mentioned the state of As or Ik, we will use higher state. That means it is cupric, that means valency 2, mercuric valency 2. When will you use if it is not mentioned in the question? If it is mentioned, then it is given. And when silver is mentioned, silver nitrate, silver chloride, that means they are not given whether it is argentus or argentic. In that case, I have to use this thing. Okay, that means argentus. Okay, the elements with valency 2 now. The elements with valency 2, that's also a little Bengali poem, meaningless, Hajabara type, Babul Tabul type. So that is what? You know that Coca-Cola, what to say? Here we say Coca-Cola. Coca-Cola. Ka means ka, ku, la means lead. So Coca-Cola. Then what? Jane na bhola. Jane means Zn. Na means nickel. Bhola means barium. Jane na bhola. Magh mashe. Magh means magnesium. Mashe means manganese. Fagun ashe. That means ferrous. Ashe means argentic. Listen, Ag plus 1 I have finished here. The last one, Ag plus. It's argentic. And so many metals with positive radicals. So many metals with positive radicals with valency 2. So you see that Coca-Cola, Janena, Bhola, Magh, Mashe, Phagu, Nashe. Coca-Cola, Janena, Bhola, Magh, Mashe, Phagu, Nashe. Okay? So many elements. And it's really confusing to remember the valencies of all these together. It's a very nice poem. Cobalt, calcium, copper, lead, zinc, nickel, barium, magnesium, manganese, iron and silver. You see, I have mentioned copper here also. That was cuprous and here it's cupric. Ag here also, argentus, argentic, all will have valency 2 plus. Okay. Now, the elements with valency 3, positive radicals with valency 3. What does it have? Usually aluminium, Al, Au, boron, B. These are the chromium, Cr. These are the main positive elements with valency 3. Valency 4 usually carbon and silicon. They have valency plus 4, plus 3, plus 2. These are the important what we come across in our regular courses. There are many other radicals. You may get it in your book, any of the book, Dalal or Concise, any book here. Now I am going to mention two complicated chemical ion, negative radical. One is ferrocyanide and the other is ferricyanide. Listen that both of the formula of both of them are same. It is what? FeCN6. It is what? FeCN6. So how will I distinguish between them? Which one has ferrocyanide, which one is ferrocyanide? You see that ferro means ferrous is here. formula is Fe(Cn)6 and its valency is -4. Its valency is -4. For ferricyanide, its valency is -3. So only by their valency we can distinguish ferrocyanide Fe(Cn)6, ferricyanide Fe(Cn)6, but their valencies are different. Similar to radicals. Here MnO4. MnO4, it means manganate, but it simultaneously means permanganate also. There are two different kinds of ions, MnO4 manganate, MnO4 permanganate. But permanganate, when you are saying the word permanganate, it has valency 1. When you are saying the word manganate, it has valency 2. So this is the some shortest way to remember the valency. So for the next class, we are going to make the formulas, okay, some of the formulas. Okay, till then, bye.